Welcome to Algebra 1, Lesson 39 with Miss Barrett. We're going to start this lesson with the Lesson 38 practice answers. So in Lesson 38, we talked about finding or solving for the inverse of a function. So we had the function f of x equals x plus 8 raised to the power of 1/3 minus 5. Our first step is always to switch out or substitute y for f of x. So where we had f of x, now we have y. Then we switch the location of x and y. So it used to be y equals x plus 8. Now it's x equals y plus 8. Okay? And after you switch x and y, then you can start solving for y. Okay? So the first thing we need to do is we have to add 5 on both sides. So we have y plus 8 raised to the power of 1/3 minus 5. If I want to get y by itself, I cannot just start moving this 8 or moving this 1/3. I have to start with this -5 because it's separate from the y plus 8 raised to the power of 1/3. So I'm going to add it doing the inverse operation on both sides, which gives us x plus 5 equals y plus 8 to the 1/3 power. Okay. Now, in order to get, the next step is to get rid of this exponent. Now remember, when you have an exponent, in order to get rid of it, you're going to raise it to an exponent that's going to make it equal 1. So if we have 1/3, we're going to raise 1/3 to the power of 3. Because the rules of exponents says when you raise an exponent to an exponent, you have to multiply them. So 1/3, and that's what we did here. 1/3 raised to the power of 3 is really saying 1/3 times 3, which is 1 times 3 is 3, and 3 times 1 is 3, which equals 1. So I raised the right side of this equation to the power of 3, and that gives us the exponent 1. And then I raised the left side to the power of 3, because what you do on one side, you must do on the other. So then we're left with x plus 5 raised to the power of 3 equals y plus 8, because y plus 8 to the first power is just y plus 8. Okay. Now we have to subtract. Now that was that step right here. We raise it to the power of 3. Now here, the next step is we're going to subtract 8 on both sides. We want to get y by itself, so we add 8. It was adding 8. So in order to get rid of the 8, we're going to subtract 8 on both sides, which gives us x plus 5 to the 3rd power minus 8 equals y. Now y is by itself. We've gotten rid of everything on that right side. So all I did here on this step is I just switched around the equation and put the y in front, because we're used to seeing the y in front here. So now we have y equals x plus 5 to the 3rd power minus 8. And the very last step, which really isn't math, is just substituting f inverse of x. Okay, that's what this means, f inverse of x. Okay, so what this means is f inverse of x equals x plus 5 to the 3rd power minus 8. That means that this function is the inverse of the function we originally had. It's the opposite of the function we originally had. Okay, so this is our original function. This is the inverse of that function. And we did the same thing in this one. We originally had f of x equals 3x to the 4th power plus 2. We did all of our steps. Okay, and I wanted to make sure to pinpoint this step, y to the 4th power. In order to get rid of that exponent, we raised it to the exponent 1/4. Because remember, when you raise an exponent to exponent, you're really multiplying them. So 4 times 1/4 equals 4/4, which is 1. Okay. Now, when you have a fractional exponent, you must make it a radical. So we had x minus 2 divided by 3 raised to the 1/4 power. That's basically taking the 4th root of that fraction. So whenever you have an exponent, as a fractional exponent, you must write it as a root. Okay, so if let's say it was 1/3, it would be the 3rd root. Let's say it was 1/5, it would be the 5th root. Okay, and then the last step is always to take the substitute inverse of x for y. Now what this means here is that this original function, f of x, this function here is the inverse of that function. That's all it means. Okay, I will post these on Google Classroom so you can see and have these notes. Now today, lesson 39, composite functions. And the reason why we're doing composite functions is composite functions are going to help us with inverses. Okay, it's going to help us with inverses. Now, let's say I gave you this function. I said f of x, so the function of x, which is f of x, which is read the function of x, equals 2x. Okay, so if I said find f of negative 6, basically what I'm saying is here is that f or x is equal to 6 or negative 6, right? So if I give you f of x equals 2x and I say find f of negative 6, what does this mean? This means x is negative 6, and you're going to plug in negative 6 for x and solve. Okay? We already know how to do that, right? All we're doing is substituting negative 6 for x. So if I say f of x is 2x, then you're going to say f of negative 6 equals 2 times negative 6, which equals negative 12. So the question is, what is f of negative 6 for the function f of x equals 2x? Well, it's negative 12. All we did was we plugged in a negative 6 for x and we solved. Well, what we're going to do with composite functions is the same thing. The only thing that's different is we're going to plug in a function into another function for x. So what is a composite function? A composite function is created by combining two or more functions. So for example, if I have the function f of x equals 2x minus 1, and I have the function g of x equals negative 5x plus 2. And I'm telling you to find the composite function h of x, which is a new function, and we're going to create by finding f of g of x. So that's how it's read. The new composite function, I want you to calculate a new composite function that equals f of g of x. Okay, what does this mean? You start from the inside. So we're going to start from here. That means you're going to take this function g of x, which is negative 5x plus 2, and you're going to plug it into the function f of x for x. So let's write out what that means. That means plug the whole function, I want you to write this. Plug the whole function g of x into f of x for x. Okay? So we're going to plug g of x, wherever we see x in the function f of x, we're going to plug in the whole function g of x. So that means if I have g of x, so f of x is 2x minus 1, right? So f of x equals, so f of g of x is going to equal, I have f of x, I'm plugging in g of x wherever I see x. It's going to equal 2 times so instead of it being x, I'm going to plug in g of x, which is negative 5x plus 2. 2 times negative 5x plus 2 minus 1. Okay? I took the function f of x, right? We're starting from the inside. So you take the function g of x, right? You start with g of x. You're going to plug in g of x, which is negative 5x plus 2, into f of x. So I'm plugging this whole thing into f of x for x. Okay? So it becomes 2 times negative 5x plus 2 minus 1. Now, when I solve that, I'm going to distribute, right? That's going to give me negative 10x plus 4, and then minus 1, which equals negative 10x plus 4. I'm sorry, negative 10x stays the same because there's no like terms. And then negative 4 minus 1 is positive 3. This would be the answer. Okay? So the goal here is to start from the inside. We start from the inside. We're taking g of x and we're plugging it into f of x. Taking g of x and plugging it into f of x. And you get out a function. This is now the function h of x. Okay, so right here I'm going to put h of x. Okay. And that's really what composite functions are. We're combining these two functions. We're plugging one function into the other. Let's look at some more examples. This shouldn't say 9 through 16. This should say 1 through 6. Okay, 1 through 6. So we have two functions, f of x equals 2x, and we have g of x equals 3x minus 4. Okay, number 1 says, find the composite of this function. So I want you to find the composite h of x when equals f of g of x, which is just like the example. So what does this mean? This means we're going to plug g of x into f of x. Okay, for x. Just like we did up here. So we're going to take our g of x and we're plugging it into f of x for x. So what that looks like is, f of x, so f of g of x equals, f of x is 2x, but instead of 2 times x, I'm going to put 2 times 3x minus 4. Okay, 2 times 3x minus 4. All I did was I took this 3x minus 4 and I plugged it in wherever I saw x. Now, in order to solve this, we're going to distribute. Remember, anytime you see these parentheses and there's a number in front, that means you have to multiply. So we're going to do our humps. So that's 2 times 3x, which is 6x. And then 2 times negative 4, which is negative 8. So, therefore, h of x, which was f of g of x, equals 6x minus 8. And this is our answer. Okay. So, you're combining two functions and you're getting out a function that's called a composite function. So, h of x is the composite function. All right, let's do number 2. So it says, find the composite h of x when that equals g of f of x. So we're going to start from the inside. Always start from the inside. We're taking the function f of x, which is 2x, and we're going to plug it into the function g of x. Start from the inside. You're taking f of x and plug it into g of x. So plug, what does it mean? It means plug f of x into g of x for x. Okay, wherever I see x in this g of x, I'm going to plug in f of x. So that's going to become, okay, h of x equals g of f of x, which equals 3 times x, which is now 2x, minus 4. Okay, so I had 3 times x. Instead of x, now I have 3 times 2x, because that's f of x, minus 4. Have to do your distribution. Okay, so now h of x, and I'm not going to rewrite g of f of x, equals 3 times 2x is 6x minus 4. Can't do anything with that 4, so this is the answer. So the composite g of f of x, or h of x now, is 6x minus 4. Now, there are situations where you can plug a function into itself. For example, find the composition of h of x equals f of x. So what this is saying, what does that mean? Again, start from the inside. So I'm starting from the inside of these parentheses. What does that mean? That means take f of x and plug it into f of x for x. Plug f of x into itself for x. Okay. Take f of x, plug it into f of x for x. So then that means that h of x equals f of x is going to equal, so 2x, so it's going to be 2 times, instead of being 2 times x, it's going to be 2 times 2x. Okay, I plugged f of x into itself. Now, to solve that, h of x equals, now I'm going to distribute, 2 times 2x equals 4x. And that's my answer. Okay, Remember, you always start from the inside. Okay? So we start here. We said we're going to plug in the function in the inside into the function in the outside. Okay. All right, let's do number 4. We have h of x equals g of x. So I'm going to take g of x, start from the inside, this yellow part. I'm going to take g of x and I'm going to plug it into itself. So what does this mean? It means plug g of x into itself for x. Substituting. So h of x equals g of x, which is going to equal, so g of x is 3x minus 4. So it's 3, instead of being 3 times x, it's going to be 3 times 3x minus 4. See how it was x, and now it's 3x minus 4? Okay, and then I still have that minus 4. So now h of x, which is our new function, is going to be, distribute that 3 to the 3x and to the negative 4. It's going to be 9x minus 12 minus 4. And I can simplify this, okay? So then 9x minus 12x minus 12 minus 4, well, negative 12 minus 4 is negative 16. So it's going to be 9x minus 16. I cannot do anything with that 9x because there is no like term. So h of x is now 9x minus 16. All right, so it gets a little bit more complicated sometimes, like 5 and 6. If you see here, we have h of x equals, and let me make sure you can see this, f of g of negative 1. F of g of negative 1. So that means if we start in the inside, we're going to plug negative 1 into g of x, and then we're going to plug that answer into f of x. So the first thing we have to do here, plug in negative 1 into g of x for x. So that means we have to find g of negative 1. So if g is 3x minus 4, we have to find g of negative 1. So we're going to plug in negative 1 for x. So that becomes 3 times negative 1 minus 4. So 3 times negative 1 is negative 3, minus 4 is negative 7. Okay? So now we're going to take this negative 7, and our step 2 is to plug negative 7 into f of x. So now we first found g of negative 1, and g of negative 1 was negative 7. Now we're going to take this negative 7 and plug it into f of x, which is, so it becomes f of g of x is basically saying, g of negative 1 is basically saying f of negative 7. Okay? Let me make sure that I'm clear that this is f of g of negative 1. G of negative 1 was negative 7. So now I'm basically plugging in f of negative 7. So wherever I see x in the function f of x, I'm going to plug in negative 7. Okay? So then that's going to be 2 times negative 7. Okay? Which equals negative 14. So basically, what we did was plug in g of negative 1, which equals negative 7, into f of x. Okay. And so therefore our final answer is h of x equals negative 14. Okay. All right. I'm going to rewrite this again. So first thing we did was we found g of negative 1. So we plugged in negative 1 to g of x. So g of negative 1 was 3 times negative 1 minus 4, which is negative 7. Now, because we're trying to find the composite function f of g of negative 1, we're going to take g of negative 1, which is negative 7, and we're going to plug it into f of x. Okay, so it becomes f of negative 7. So we plugged in negative 7 to f of x, which is 2 times negative 7, which is negative 14. Therefore, our composite function here is h of x equals negative 14. Let's do it again. We want to find h of x equals g of f of 2. So our first step is to number 1, plug 2 into f of x, because we're starting in the inside, f of x for x. So basically find f of 2. Okay, and f of 2 is going to be 2 times 2. Right? Because our original function was 2x. Okay, now we're finding f of 2. We're just doing 2 times x, which is 2. So that's going to equal 4. Okay. Now step 2 is to now plug this 4 into g of x. Plug 4 into g of x. Okay. Right? We started from the inside. F of 2 first. We have to find f of 2. That was 4. Now we're going to plug that into g of x. So it becomes g of f of 2, right? So it becomes g of 4 because f of 2 is 4, right? So g of 4 is going to be 3 times 4 minus 4. And 3 times 4 is 12, minus 4 is 8. So the answer here is h of x equals 8. Okay. All right. So for your practice, that's what I'm going to make sure you all guys understand. You're starting from the inside always. Always start from the inside. For your practice, it's going to be very similar problems, except for you have different original functions. You're going to be asked to do the same thing. Find f of g of x, g of f of x. Find f of x, g of x. And then find f of g of 3, and then g of f of negative 2. Okay, use your notes. If you have any questions or concerns, please do not hesitate to email me or send me a message in Google Classroom. You can also replay your videos if necessary. Okay, hope everyone has a lovely day. Bye.